Okay, so let's start your snap for data structure and algorithm. Uh, can you explain linear probing to me?
Okay.
Yes.
So this is one technique to solve the problem of collision in case of hashing. So in hashing, suppose there are many keys and so there are 10 slots. So suppose the key mod 10 is the formula for hashing, or we can say the hash function. So if at any point collision has occurred, suppose two elements are collision happens because both are supposed to enter into the fifth slot. So then the element in the second element which is creating the collision will go and sit into the next slot that is available. That means if the sixth slot is available, then it will enter into that slot. If not, then it will go to the seventh and so on up to the 10th slot. Even if it's not available in the 10th slot, then it will again start from the first slot. It will find out. That's the probing. It will search all the consecutive, all the following slots, whether available or not.
Okay. There is a problem with the linear probing called primary clustering. Can you explain that?
No, I'm not aware.
Okay. Can you let's say that you have to detect a cycle in the linked list. How you can do that? And you cannot store the addresses of linked list into an array.
Okay. Okay. So first we have to take two pointers such that one pointer is like proceeding by one next means link next node next, and another is node next. So one is moving twice faster, and one is moving by one step, one node.
Okay.
So
Okay.
in that way
Done.
there will
Okay. Can you let's say that you have three sorting algorithms: insertion sort, bubble sort, and selection sort. And in these algorithms, what we basically do is we find the number of swaps and number of comparisons in order to find out the time complexity, right?
Yes.
So in which of these sorting algorithms, there will be always be the best case for number of swaps? Which algorithm will give you the best case of number of swaps every time?
Selection sort.
Okay. Okay. Can you tell me the recurrence relation for binary search?
Yes. Tn equals to T of n by 2 plus some constant.
Okay. And in binary search, what we usually do is we divide the array into two parts, right? So
Yes,
have you heard of ternary search?
yes.
And what will be the recurrence relation for ternary search?
Tn equals to T of n by 3 plus some constancy.
Okay. So if you compare the time complexities of ternary search and binary search, which will be more? Or will they be equal? Or
For binary search, it is log n base of 2, and for ternary, it is log n base of 3.
okay.
So, like n is a very large number. So actually, it won't much depend on the base value, whether it is 2 or 3. Mainly, n is quite large, so both will be, I think, asymptotically equal.
So you are saying that if I take log 2 base n, and then I take log 10, log 2 base, log n base 2, and then I take in other case log n base, let's say 10 lakh. So will there be any effect then?
So one is the n with base 2, and another is n with base 10,000.
10 lakh.
10 lakh. Sir, 1 minute. Okay, I'll just calculate.
Just calculate the time. Just compare the time complexity for log 2n and log 3n.
Okay.
Just do that.
Log 2n and Yes. So like log, I'll show you in the camera.
Yes. Okay.
So if we are doing this, then this is coming as log 3 base 2, which is a constant. So both are asymptotically equal.
Okay, fine. Can you tell me the steps to insert some element in the linked list? Like you have to insert some element at place 4 or 5, whichever you want. So how you insert the element into the linked list?
Okay. So first the linked list is given. Now suppose at the second position, we want to place something. So from the first node, there was a pointer to the second node. So this pointer has to be removed, and that will point to the new node, and that new node will now point to the previously second node. So the previously second node becomes the third node, and we are inserting in the second position.
So the order in which you have answered this question, what if you are saying that you will remove the link between the second and third, or first and second, right? You
Yes,
will
first
remove
and
the link
second.
between the first and second, then first point to the new node, and new node will be the point to the second that was before,
Yes.
right? So if you remove the connection between 1 and 2, how you will give the address to the new node where to point after that? That linked list will be lost, right?
Mm. Oh yes, wait. Uh, so we can take a temporary variable, a temp, that will store the, I mean, a pointer variable, temp, that will store the address of the that third node. Means that will
And what
become
if
the
I
third.
want to save that space? I don't want to give any new variable some space. So I don't want to use any new temporary variable. Then how you will do it?
Okay, okay. Then what we can do is we can take the new node first, and the new node will first point to the third node, and after that we remove the pointer that was previously present and place it in the point it to the new node.
Okay. So let's say that you have been given a tree. Let me give you a tree first. And the pre-order of the tree is 10, 7, 5, 8, 12, 11.
This is pre-order.
This is the pre-order, yes.
Yes.
And
Yes.
you have been told that it is a binary search tree.
Okay.
Can you give me the in order for this?
Okay, okay, sir. In order. In order. In
How
order.
will find the in order?
Sir, once again, sir. So what you
Can
said?
you tell me how you will find the in order? Like what's the process?
Sir, since this is the pre-order given and it is said that this is BST, so I have drawn the tree first, and then after that I can do the in order.
Okay.
So the in order will be 5, 7, 8, 10, 11, 12.
So okay, so let me give you your feedback. तो श्रेयसी ठीक है, इसमें एल्गोरिदम इतना कोई वो नहीं है, जैसे लास्ट में जो आपने टीओसी और ऑपरेटिंग सिस्टम का दिया था उसमें ऐसा था कि थोड़ा टेक्निकल टर्म्स आप मिस कर रहे थे, तो वो नहीं है इसमें। टेक्निकली नॉर्मल, मतलब टेक्निकली स्ट्रांग है ये आपका सब्जेक्ट और ठीक से आंसर कर रहे हो। दूसरा, थोड़ा जो चीजें, मतलब अब जैसे जो लास्ट क्वेश्चन मैंने आपसे पूछा वो इसीलिए नहीं था कि आपको प्री और पोस्ट ऑर्डर बताना था, वो इसीलिए था कि एक प्रॉपर्टी होती है वो आप यूज करते हो कि नहीं करते हो। बीएसटी की प्रॉपर्टी होती है उसका इन ऑर्डर हमेशा सॉर्टेड एरे होता है, तो आपको इस पे टाइम नहीं स्पेंड करना था, आपको जस्ट इसका हाँ
Yes, I understand.
जो छोटी छोटी चीजें इनका थोड़ा ध्यान रखना है। और एक जैसे आपने प्राइमरी क्लस्टरिंग मिस करा। अब
हाँ,
लीनियर प्रोबिंग क्या होता है कि एक नहीं मिला तो दूसरे पे चेक करेगा, दूसरा नहीं मिला तीसरे पे चेक करेगा। तो प्राइमरी क्लस्टरिंग क्या होता है, वो इशू होता है लीनियर प्रोबिंग का। वो ये होता है कि मान लो जैसे आपने 2 को मॉड 10 में डालना है, तो सेकंड प्लेस पे डालोगे। जब 12 आएगा तो 12 क्या करेगा, सेकंड पे नहीं मिलेगा तो थर्ड पे जाएगा, और
yes,
ऐसी 22 फोर्थ पे जाएगा, 32 जो है वो फिफ्थ पे जाएगा। तो जब
हम्म,
42 आएगा तो जो पाथ हमारा पहले वाला जो हमारा की था वो फॉलो कर रहा है, वही पाथ आगे वाले भी फॉलो करेंगे। मान लो एक पॉइंट पे वो टेबल पूरा भर जाए, तो वो 10 टाइम्स चेक करेगा सारे स्लॉट्स को खाली है या नहीं। फ्रेंड में उसको जब नहीं मिलेगा तो बोल देगा भाई कुछ नहीं मिला मेरे को। तो जब नेक्स्ट उससे 42 के बाद 52 आएगा, तो वो भी पूरा पाथ फॉलो करेगा, सेम ही पाथ फॉलो करेगा। तो इसीलिए जो लीनियर प्रोबिंग है उससे ये दिक्कत आती है कि अगर एक की को स्लॉट नहीं मिल पाता है और वो कोई पाथ फॉलो कर रही है स्पेसिफिकली, तो वही पाथ जो है वो अगले वाले भी बार 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 फॉलो करेंगे। तो ये प्राइमरी क्लस्टरिंग होता है।
Okay, so basically primary clustering is the drawback.
ड्रॉबैक, यस यस।
Okay.
ड्रॉबैक एक ही है कि हाँ बार बार ढूंढना पड़ेगा।
Mm-hmm.
ठीक है। तो इसमें ठीक है, आपको ज्यादा इतना कोई रिवीजन की जरूरत नहीं है, थोड़ा बहुत देख लिया करो कि इन टच रहो बस सब्जेक्ट से। बाकी इतना कोई इशू नहीं है, क्वेश्चन आपने सही आंसर करे थे सारे लगभग।
Yes, sir. Yes.
ठीक है, ओके डन।
Okay, sir. Thank you, sir.
ओके, ऑल द बेस्ट।
Thank you.